Hi, here are your notes on fronts. So I'm starting with this weather map because it has all of the fronts today. This is Tuesday afternoon's map. And you can see the blue line here with the triangles, that's a cold front. And the red here with the circles, that's a warm front. This little pink one is called an occluded front. You'll learn more about that later. And you'll notice that a lot of the rain and snow on this map is happening right next to the fronts. So a front is a place where a lot of stormy weather occurs. So the idea is you're going to learn what happens at the different kinds of fronts and why they cause stormy weather. So that's our goal for these notes. So a front is a boundary that separates air masses of different temperatures. And since they have different temperatures, they have different densities. So remember I said that almost everything in all of this class happens because of density or convection. The weather that happens at fronts, it's the exact same thing. It happens because of different densities. And a front is named after which air mass is displacing, which means it's moving in and replacing the other. So for a warm front, warm air displaces cold air, and for a cold front, cold air displaces warm air. So for both types of fronts, you have warm air and cold air that meet. The difference is for a warm front, the warm air is pushing the cold air out of the way, and for a cold front, the cold air is pushing the warm air out of the way. You can think of it as which temperature air is winning the battle. Here are the weather map symbols. If you don't have colored pencils, you can just write the color. So a cold front is blue with triangles, and the triangles point the direction the front is moving. So you can see these arrows, they represent the wind direction. The cold air is behind it, and the warm air is in front of it. So the cold air is pushing the warm air out of the way. A warm front is these circles, half circles, and warm air on this side is pushing cold air out of the way. So this is the direction the front is moving. A good way to remember it is the little points on the cold front are pointy like icicles, and the little half circles are warm like suns. Here's how density comes into play with fronts. When the two temperatures meet, which air is more dense and which is less dense? Yeah, the warm air is less dense and the cold air is more dense. So then when the two of them meet, which air is going to be forced up and which will stay down by the surface? Think about their density. Yeah, the warm air is going to go up and the cold air will stay at the surface. Because the warm air is less dense, when the two collide, one of them is going to have to go up and it's going to be the less dense one. So why does this matter? Since air is forced to rise, it's going to cause cloud and precipitation. Rising air almost always means clouds and precipitation. Why is that? Well, when air rises, it cools, and if it cools below the dew point, then condensation occurs. Now the reason it cools off when it rises is because, remember, it gets colder as you go up, so it's going to cool off as it goes up, and it's also expanding, and that makes it cool as well. So at a front, the warm air is forced upwards, which makes it rise, which makes it cool, which causes condensation. And that condensation results in clouds and precipitation. So this is what it looks like for a warm front. Here's the cold air, and here's the warm air. And the warm air is pushing the cold air out of the way. And as it does, it goes upwards. And here you can see the clouds that are formed. You get nimbostratus clouds, which, remember, that's the steady rain clouds. And then there's alto and cirrostratus, so stratus clouds higher up, and even cirrus clouds. So this is the kind of front that a cirrus cloud will tell you it's coming, because you get these really high clouds forming, and then a couple days later the front gets to you. This is a picture of a cold front. Here's the cold air that's pushing the warm air out of the way. And the difference is, when it pushes, it kind of pushes like a bulldozer, so the warm air has to go up really fast. When it does, you get cumulonimbus clouds, and remember, those are the thunderstorm clouds. So you're going to get heavier precipitation here and thunderstorms. So what's the difference between cold fronts and warm fronts? At a warm front, the warm air slides up and over the cold air more gradually, so warm fronts produce light precipitation and sometimes even only clouds. But at a cold front, the cold air violently pushes the warm air up, so there's more vertical motion, so that means more severe weather. It also means a more dramatic temperature difference. So the difference between the temperature before and after the front is going to be bigger because the whole thing happens faster. So here's a summary of the weather patterns you see at each front. For a warm front, you get a steady rain and the temperatures are going to go up. And at a cold front, temperatures drop. You see thunderstorms or downpours, and clear and cool weather is going to move in. We're always really happy when a cold front happens in the summer, so that would be when you have those thunderstorms and then the next day it's not as hot. These two other fronts you don't need to know for this class, so I'm telling you about them because you might see this symbol on a map, and those of you looking for an extra challenge can learn these as well, but it's not required for this class. So a stationary front, the symbol is right here. It's kind of like a warm front, but it moves very slowly, if at all. So this is the kind of front you have when you have the same weather for an extended period of time, which is often similar to warm front weather. So if it rains for several days in a row, you probably have a stationary front. The other type in purple, and we had one of those on our weather map, it's the most complicated type. And it can happen when a cold front overtakes a warm front, so the two fronts kind of crash into each other. It happens because cold fronts move faster than warm fronts, so if a cold front crashes into a warm front, you get an occluded front. And you get loads of precipitation at those. Once again, these two are not required, they're optional for this class. So now let's do a quick check for understanding. See if you can figure out which type of front causes the same weather for a few days at a time, which has the steepest slope and the most violent weather, which can be predicted by seeing cirrus and then stratus clouds, which causes thunderstorms, which is that the symbol of, and for which one does the weather get colder after it goes through. Pause and figure it out, and then press play when you're ready for the answers. Okay, here are the answers. A stationary front causes the same weather for a few days. And once again, I said that one was optional for this class, so don't worry about it if you didn't get it. A cold front has the steepest slope and the more violent weather. A warm front can be predicted by seeing cirrus and then stratus clouds. A cold front causes thunderstorms. That symbol is a warm front. And the weather gets colder after a cold front goes through. All right, write down any questions you had, and we'll go over them in class tomorrow. Thank you.